Can you hear me? Is the voice clear?
Yes, sir. Good morning.
Good. Okay, all right. So we'll start where we had stopped yesterday. So we'll just take one example of omitted variable and multicollinearity using variance inflation factor on R. And then we proceed ahead with linear hypothesis test and prediction. So can you all see the screen?
Yes, sir.
Okay, all right. So I request all of you to open our studio and load GPA data, GPA1, sorry, from package Woolrich. And um, as usual, we'll just explore data for a minute. We'll just see what are the variables. So yesterday we had talked about this data set. So these are the variables that you have. You can see the data matrix is a combined mixture of quantitative and qualitative variables, whereby these qualitative variables are turned into numerical variables by assigning a dummy to them, which we call as dummy variables. We'll also discuss about dummy variables in brief today. So what we'll do is we'll run a regression of college GPA on high school GPA and achievement test score and obtain its coefficients. So please do that. So what I do is yeah,
Sir, so as we got this data set which has a lot many variables,
yeah.
so how do we decide that you told that we have to make a regression equation for the two variables, ACT and high school data. But
हाँ
if
जी.
we don't have that knowledge that we have to regress on these two, so initially what we'll do?
See, ये तो डेटा सेट है हमारे पास, हम एग्जांपल देख रहे हैं. जब you run your own equation, then you know which variables to work with, right? This is the pre-given data set to you, where the example is that we are running this regression. But when you have all these variables in front of you, then it depends on you. आपका क्या theory कहता है? Let's say you want to understand whether age has any effect on the college GPA, earned by an individual or not. So ये पूरा theoretical specifications will depend on what exactly you're trying to estimate or what exactly you're trying to find out. और वो this as a question, if you're asked in question, then you'll definitely be given that you have to run this regression, you have to find this causal relationship. But when you're undertaking your own project, in that case you have to decide, or your theoretical specifications will decide कि आप regression किसका किस पे करोगे. Is that clear?
Yes, sir. Sure.
तो वो आपके मतलब जो भी whatever model that you're trying to build, whatever relationship that you're trying to find out, that's how you will run your regression. ये तो question है, ये एक example है. That's why I'm saying that you simply run a regression of college GPA on, just to explain the example of omitted variable case. I have taken this data set. ठीक है?
Yes.
All right. So I stored my regression results as REG, and I want to get the coefficient of this, assuming it to be a true equation. So I want to get coefficient. So I'll just write coefficient of running a linear regression model of COLGPA on HSGPA plus ACT. And the data that I have to use is GPA1. So this is what you get as you're running a regression of college GPA on these two variables. So जो भी आपको coefficient आएगा, if you just simply write REG. Okay. So these are the coefficient and these are the estimates that you get. So in this equation, what we get here is that The intercept term has an estimate of 1.29, if I just round it off to two decimal points. High school GPA has 0.45 and achievement test score is 0.009. The first interpretation when you get these, they are the partial regression coefficients. So achievement test score having a coefficient of 0.009, what it means is that in the presence of high school GPA, if there is 1 unit increase in the achievement test score obtained by a student, his or her कॉलेज जीपीए और एवरेज कॉलेज जीपीए, ये हमेशा याद रखिएगा कि जो y hat है वो एवरेज वैल्यू ऑफ y है, because of population regression function that we get, we write it as expected value of y on the data matrix. So always get this point when you interpret it, the dependent variable is always explained in terms of the average value or expected value. So if there is a change of ACT by 1 unit, your expected or average value of college GPA of that student is going to go up by 0.009 units. Similar interpretation for a high school GPA as well. And from this, you can see that the major proportion of variation in the college GPA earned by an individual gets explained by high school GPA. This is reflected in the coefficient estimate value. But interpretation remains in the same manner. Why you always explain in terms of average value or expected value. अब इसमें अगेन डिपेंड करेगा कि यूनिट्स ऑफ मेजरमेंट क्या है. सो इस केस में तो मार्क्स है या व्हेन योर यूनिट्स ऑफ मेजरमेंट जैसा रहेगा वैसा ही आप इंटरप्रिटेशन दोगे. अगर लॉग रहेगा, so you understand that these the estimates, they are nothing but the slope coefficient. Slope is what? Del y upon del x. So jidhar bhi log hai, udhar agar if you take the first order differential, that gives you the proportionate rate of change. So in case, in this example, suppose we were running a regression of log COLGP on log HSGP, log ACT. तो जब आप जो भी coefficient estimates you obtain, they are called as constant elasticity coefficients. Because in that case, the partial regression coefficient, if you actually explain in terms of slope, that will be del log y upon del log x. और if इसको थोड़ा सा algebraically manipulate करोगे, this will become elasticity of y with respect to x, whether it's x1 or x2. So in case of log-log model, the coefficient that you have, they are also referred to as elasticity coefficients, and they're constant because, once the parameters are estimated, it's just one value, and that's why they are called as constant elasticity. अगर semi log है, तो जिधर log है, whether it is in y or it is in x, so if you have log y is regressed on x's, or if you have y regressed on log of x, that's how interpretation will change. So जो log होगा, if you take the differential of that log, that will give you the proportionate rate of change. So उसको absolute करने के लिए और percentage change में लाने के लिए you multiply that by 100. And this is how normal interpretation will go. But all the time, y always change in the expected amount due to a unit change in x. That's how we also understand how slope should be. All right. So in this case, we were just trying to understand the problem of omitted variable bias. So omitted variable means कि आप कोई भी एक relevant variable था, which you either happen to ignore or you were not able to count them explicitly in the model. That's why we are calling it as omission of variables. So this is the true coefficients, or this is the partial regression coefficient when you have, assuming that this population regression function is true. Now, let us say you want to run a regression excluding, let's say, HSGPA, that you're just simply running a simple linear regression of college GPA on achievement test score. So we'll just do that. Let me call it as regression 1. All right. Again, coefficient LM GPA is regressed on ACT alone. So in this case, we are ignoring or we are not including the data or the variable, sorry, HSGPA. So now if you see the regression coefficient, this is the, so now you see in the absence of HSGPA, that is high school GPA, you can see there's huge difference in the coefficient with achievement test score. In this simple linear regression, the coefficient of ACT, that is 0.027, it tells you how expected value of college GPA earned by an individual increases when you have 1 unit increase in ACT. And in this case, since there are no other variables, so you're not keeping anything constant. But in this case, 0.009 you obtain in the presence of high school GPA, that is controlling for high school GPA in the model. So you can see this difference. और जो हमने कल क्या देखा था कि in case of this bias or in case of this omitted variable case, ये जो estimator आपको आता है, that is the estimator that you get in the case of linear regression, simple linear regression. It will be the coefficient that is attached in the multiple linear regression plus the correlation coefficient of the omitted variable with the explained variable multiplied by the coefficient attached with the excluded variable in the multiple linear regression. So let us do that. For in order to obtain this whole bias, first we'll run a regression of ACT on HSGPA, or sorry, HSGPA on ACT, because in this case we are excluding HSGPA. So what I'll do is I simply write it as regression 2. Again, what I'm doing is I'm running a regression of, sorry, HSGPA against ACT, and the data set your GPA1. अब जो यहाँ पे जो कोएफिशिएंट आएगा आपको, that will be your nothing but the correlation coefficient, or you can say regression coefficient of HSGPA on ACT. That is how much variation in HSGPA is explained by the achievement test score. So if you just regress, just get this value. So now you see, now the ACT, that is in this regression, the coefficient that you get is 0.3889675, or to round it off, it will be 0.39. अब जो formula है, that is omitted variable bias का, that we can easily explain. That will be ये जो coefficient है in the true model, that is ACT. So this, that is beta 1 hat plus, sorry, in this case beta 2 hat plus the correlation coefficient that you obtain from here multiplied by this 0.45. So let me just write it here. So original regression का मुझे ACT का coefficient चाहिए. So I'll just simply write it as REG, and you can either write $sign or you can just have in the bigger bracket. So REG का coefficient मुझे चाहिए ACT का. Simply write it ACT. Then the next thing that I need is high school GPA ka actual beta coefficient in the multiple linear regression. So again, I'll see REG, bigger bracket, need for HSGPA. And this I will multiply it with the regression 2 coefficient that we have for ACT. So I just multiply it with REG2, sorry, REG2, और उसका मुझे क्या चाहिए, उसका मुझे चाहिए ACT का कोएफिशिएंट. So I'll simply write REG2 ACT. Now you see the value that we get is 0.2706397, which is exactly this value that we have got. So the entire purpose of this exercise was to discuss the problem of omitted variable bias case कि अगर true population regression function कुछ और कहता है and instead you run a regression by excluding that relevant variable, and the precise reason why it is called relevant variable is because it explains the variation of y in the movement of y in the presence of the other explanatory variable in the model. So if you exclude that variable out of the regression equation, the estimates that we get, the usual OLS estimates that we get is a biased estimate. अब वो bias either overestimation होगा or underestimation होगा. That is either it will be a positive bias or a negative bias. Bias means what? That if you take the average expected value of this OLS estimator, it will not be equal to the true population parameter. That's what it means bias. So positive bias means it will overshoot the actual average value of the true population parameter, and negative bias means it will be less than the true population parameter when you just sum or when you just take average value of these OLS estimators. This is how you solve the problem of relevant variables. So in this case, you can easily see that this 0.2706 exactly the same coefficient that when you simply ran a regression of college GPA on ACT, ignoring the presence of high school GPA, as well as this is considered. So the sign of the bias will depend on this interaction term, and this interaction term is given by this, where you have this omitted variable bias will get decided by the correlation coefficient between the explained variable and the omitted variable, and the true population coefficient or true population parameter in the multiple linear regression model, which is assumed to be true. And a bias तभी नहीं होगा when either the correlation coefficient between the excluded variable and the independent variable used in the model is zero, or in the true population parameter, the population coefficient is actually zero. In that case, it automatically becomes an irrelevant variable. And positive bias will be when correlation coefficient between the explained variable and the omitted variable is greater than zero, and also your beta is greater than zero. When both are negative, then also you'll have the case of positive bias. When either of them is positive or negative, you'll have a case of negative bias. Is this clear?
Yes, sir.
ये पॉइंट क्लियर है कि ओमिटेड वेरिएबल बायस का बात हम कैसे कर रहे हैं. बायस मींस एग्जैक्टली क्या हो रहा है यहाँ पे.
Sir, can you repeat the positive bias again?
Yeah, positive bias. देखो, sign of bias will depend on this term. You understand this? That is, जो true multiple linear regression है और जो आपने variable omit किया है उसका regression coefficient multiplied by the correlation coefficient of the explained variable which you have included in the model and the omitted variable. So positive bias कब होगा? When both of them are positive, that is correlation coefficient between x1 and x2 in this case is greater than zero, and also the population coefficient attached with the omitted variable is greater than zero. Or in the other case, when both of them are negative, because you're talking about an interaction term between them, multiplication between them. So it will be a positive bias when both of them are positive and both of them are negative. If any of them is, either positive or negative, in that case, you'll have a negative bias.
Sir,
चलेगा?
Yes, sir, got it.
Okay. Shall we move ahead then?
sir,
Shall we move ahead?
sir, I had a doubt.
Yeah, please go on.
So, sir, how do we get to know when we run a regression? How do we get to know that there has been an omission of an variable?
Correct.
And do we
So
start
for
from
that, there's this reset discuss after we are done with various example of various. Logic बोलता है कि अगर आपके पास unit specification model में कि there was a bit should
Sir, your
been
voice
used,
is
but you
breaking. Is it only for me?
forgot
So your
So
voice
like
is breaking.
still you have the
Uh,
same problem.
no, sir. We can hear you now. The time you started explaining how do we account for it, when do we account for it?
Okay, okay.
From
ठीक है, can you hear me now properly?
yes.
Okay. So the logic क्या बोलता है कि अगर if there is any variable which should have been included in the model and you forgot not to, or you forgot to include that in the model, or somehow you're not able to count them explicitly in the model. So what reset test or how the reset test goes about it is that you simply run the regression, assuming that your model is true. Then in order to test for the misspecification, what we do is we obtain the fitted values from the regression that you have got, and then we again run the regression of the dependent variable against the explanatory variables which you had already used in the model, and the polynomial terms of the fitted values from the regression. And then we test for the hypothesis. If you're using one simple term for fitted values, then we simply test for individual significance. If you're using more than one term for the fitted value, that is, we are taking the second power or third power or fourth power. In that case, we run a joint hypothesis. Then we test for the hypothesis whether the coefficient attached with this polynomial term is zero or not. So our null hypothesis is that the coefficient attached with the polynomial terms, that is fitted values of the polynomial terms, is zero, against the alternate hypothesis that if any of them is not equal to zero, you reject your null hypothesis. And then we simply carry out the F test, which will do F statistic हम calculate करते हैं, and then we compare the calculated value from the critical value. If we are able to reject the null hypothesis, meaning what? That your model that you ran is not a correct model. That is, there is some misspecification of the model. Logic क्या है कि जो fitted values है, वो fitted values is a linear combination of the regressors that we have got. And if still the higher order powers of the fitted values are still significant in the model, it means that there is some misspecification that the researcher has ran into. Now, the limitation of this reset test is two. First is it does not actually explain that how many non-linear or polynomial powers of the fitted values should be exactly included in the regression, that is the auxiliary regression that we run. And the second, on the basis of reset test, if you come to know that is, if you come to reject the null hypothesis, meaning which that your functional form or the model is not correctly specified, it does not give you an indication that which variable is missing. So that's how the limitation of this reset test again works. So again, then we go, so simply reset test gives you an indication that your model is running into a problem of misspecification. That's an indication. But what misspecification it is actually going into, that will not be given by the reset test. For that, there is improvement in the reset test, which is called your LM test. Again, it runs on the same idea. You simply estimate the original equation, you get the residuals, you then again regress these residuals against the fitted values, calculate the R square from this regression equation, and n times R square will follow chi-square statistic. Again, you calculate the chi-square and compare it with the critical chi-square. If you're rejecting the hypothesis, then it indicates that there is functional form misspecification in the model. If you're not able to reject the null hypothesis, it means that whatever model that you've run is a correct model. But again, same problem, indication कौन सा वेरिएबल मिसिंग है ये इन दोनों टेस्ट से नहीं पता चलता, and also there is no such test which actually tells you that this variable is missing. So for that, again, you go back and just do simple trial and error manipulation. You take one variable, you include the polynomial terms of the variable, and just check whether the coefficient attached with that polynomial terms of the chosen explanatory variable is significant or not. So you simply go ahead with the trial and error method. So this reset test and LM test, they both are example of indication of or exclusion of relevant variables from the equation. Now, one possible remedy that we go for or that we use for exclusion of relevant variable case is, we had discussed about it last night, that is called the use of proxy variables or instrumental variables. अब proxy variables उसी केस में work करता है when actually the variable which you're trying to keep as an explanatory variable is an unobserved variable or is a latent variable. And that's why you choose another variable which somehow explains or which somehow is correlated strongly with the variable which you cannot observe. And the second condition that the variable has to satisfy is that it should be uncorrelated with the errors or the residuals of the regression. Because the usual assumption of OLS, we must satisfy even we are running a proxy variable in the case of exclusion of omitted variable case. But again, in this case, researcher must know that, this is the variable. So in the example that we had talked about yesterday, that if you're trying to estimate wage against education and ability, and if ability is not directly observable, so in that case, the researcher uses IQ score of the individual on any aptitude test. Uh, and then, that IQ score or IQ test score is treated as a proxy variable, assuming that IQ score reflects the ability of an individual. So in this case, use of proxy variable requires a pre-knowledge on the behalf of researcher that the actual variable which he or she cannot observe can be approximated, by the use of the proxy variables. But as far as the detection of problem of relevant variables is concerned, reset test and LM test, they both work absolutely fine. It gives you an indication whether your model, is either an underfit model in the case of exclusion of relevant variable. And then you again go back and, you either read the theory or do some, algebraic manipulation with the model. You take an explanatory variables, you include the polynomial terms. Uh, Second polynomial term se nahi hota hai, you include the third order polynomials, and you simply just do this trial and error once again to check whether the true model you get by these manipulations or not. ठीक है? Shall we go ahead now?
Yes, sir.
All right. So टेस्ट तुम्हें बता देगा, बट कौन सा वेरिएबल एक्चुअली मिसिंग है उसके लिए इट अगेन is a problem that you have to just redo again and again, and then on the basis of different models you find out, then again do the reset test. Agar reset test में you're able to not reject the null hypothesis, then you actually come to know that the model that now you have run is a correct model. This is the usual procedure of moving ahead with functional form specification. All right, so let us now take one example of variance inflation factor with R. So what we do is we simply take this same data set. Or let me take another data set. So let me take the data set given as wage 1. And जो भी हमने example किया है on R, they all are examples given in Woolwich. That's how I've selected the data set on the basis of the examples that they've given. So कभी भी confusion हो, you can go back to the chapters and go through all these examples. So I've taken wage one data set from the package Woolrich. And as usual, just see how the data set looks like. So this is the new data set that we have in front of us. You have wage, you have education, experience, tenure. Again, there are some qualitative variables like whether white, non-white, then I really don't know what is the description of this new depth. North Central. I think these are the regions: North Central, South, West, professional service, professional occupation, and so on and so forth. And then you have log of wage, experience ka square, and tenure square. So these are the polynomial, or you can say modifications in the actual variable from the model. So experience square and tenure square, these are the polynomial terms. What this example does is it simply runs a regression of log wage against education, experience, and tenure. So we'll simply do that. What I do is I keep this result as I run a regression of log wage. So I'll simply take L wage because it is already given here against education, experience, and tenure. So we can simply take the summary, or we can also use the coefficient in the regression tab only. Yeah. So this is the summary of the regression that we have run. We have ran a regression of log wage on education, experience, and tenure. That is, we are trying to estimate a causal relationship between logarithm of wages earned by an individual against the explanative variables, educational attainment, experience, and tenure. Now, one thing that you should always remember that you cannot apply logarithm to any variable in the data matrix or any column in the data matrix if that column consists of negative variables, because you cannot precisely, for the reason that you cannot have logarithm of a negative variable. So in this case, the wage earned by an individual, all the variables or all the observation with respect to the column wage is positive. That's why you are able to apply logarithm to that. But always keep this factor in mind that you should not apply logarithm to the column consisting of negative values in the data matrix. All right, so we ran this regression, and the coefficient along with the estimates and the standard error, you can easily see they all are explained here. This is so this is the estimate of these estimators along with the standard error. You can easily calculate p-value, and these are the p-values or probability values, and this is how you must be able to interpret from the regression results that we get. And नीचे आप देख सकते हो, these are the residual standard error, or standard error of regression can also be called as 510 to 2 degrees of freedom, meaning which अगर dimension देखोगे तो it will be having 525 number of observations. Multiple R square is 0.316, adjusted R square is 0.3121. Basically, it tells you that the model that you are running does not explain the full variation in the logarithm of wages earned by the individual. These are now either I can calculate variance inflation factor by the manual calculation, that is yesterday we had talked about that variance inflation factor of the variable is 1 upon 1 minus coefficient of determination from the regression, where you regress the variable concerned explanative variable against all other explanative variables in the model. So in this case, if I'm talking about finding out the variance inflation factor of education, so in that case what will happen? First, we'll run a manual regression of education against experience and tenure, get the R squared from that, and you can simply again run the formula 1 upon 1 minus R squared from this regression. And that will give you the variance inflation factor of education. Similar thing you can do with experience and tenure. Only thing that you to keep in mind is that in order to get to the variance inflation factor, we run जितना वेरिएबल होगा उतना आपको ऑक्सिलरी रिग्रेशन रन करना होगा. दैट इज यू आर ट्राइंग टू फाइंड आउट द कोएफिशिएंट ऑफ डिटर्मिनेशन फ्रॉम द regression equation when you regress each of these variables against all other explanative variables in the model. Now, as you'd guess that all these things need not be done manually again and again on R. And there is this very easy command which you can simply write that, and you can get variance inflation factor for all the explanatory variables at one time. So that command is your VIF command, and that is loaded, or that comes with the package car. So in order to call that, or in order to use that command, we first must call the package car. And always keep this in mind, that if we have to use certain command from the packages need to be installed only once, but you have to call them again and again when, you know, in one particular session you have to call them once if you want to use any command from those packages. So I'll just simply use library function to call the command, sorry, package. So library car, right? Simply tell you the loading required package and so on and so forth. And then I can simply use the variance inflation factor command, which is, we simply write it as VIF. And VIF of what? The regression that we had just run. So regression is RES. So I'll simply write it as VIF RES. Now you see it gives a variance inflation factor for each of the variables that we had talked about. And either you can get it manually or you can get it like this. So variance inflation factor helps you understand, you know, how variables are correlated against each other. अब जिसका variance inflation factor बहुत ज़्यादा है, the variables having high variance inflation factor, if, you know, somehow you are able to detect the presence of multicollinearity, so जिस भी variable का variance inflation factor ज़्यादा होगा, first you remove that variable, then again run the regression, again check for the detection of the multicollinearity. If you're able to solve the problem, well and good, move ahead. If you're not, then, you know, there are some certain other measures which we had talked about yesterday, which are called principal component regression. But again, it has got huge limitations. That's why it is not being used a lot by researchers these days. But that runs again on the similar fundamental phenomena, that if you have k regressors in the original regression equation, then precisely in order to solve this k regression, what we do is we calculate principal components of these k regressors, whereby principal components are linear combination of all these k regressors. So if you have, I'm just quoting the result, if you have k regressors, you will get k such principal components, and all these principal components are the linear combination of the true regressors in the equation. The first principal component has the highest variance, meaning which जो पहला principal component that you get, it explains most of the variation in the explanative, in the y that we use, because ultimately this principal component is a linear combination of all the regressors. The second principal component will have a variance which will be lesser than the first principal component, and so on and so forth. Ideally, for k regressors, there'll be k principal components, but we did not run the regression using all those k regression coefficients. It is very much doable with, you know, using first or second principal components. And precisely why you get k principal components for k regressors is because each of these k principal components are orthogonal to each other, meaning which they all are linearly independent of each other. And that's how you resolve the problem of multicollinearity. Again, I'll send you the reference as far as the theoretical consideration is concerned, that what are the limitation of using principal component analysis, and just go through that. If required, I'll give you the syntax for running this principal component analysis as well. Again, it comes loaded with a package. You need not calculate principal component manually by yourself. You can simply run the command princr, and on the regression that you've got, and you simply get the principal component regression. But it should always be used with caution. That's why the theoretical consideration is necessary. And principal component regression, most of the time, it loses the economic significance of the variables, because ultimately, suppose even in this case only, the explanative variables that we have is education, experience, and tenure, and principal components that we get is nothing but the linear combination of these: education, experience, and tenure. That is, linear combination means having a having performed two operations, that is scalar multiplication and addition. So scalar multiplication जो है वो आपका coefficient बन जाता है. It means, so in this case, let us say, just hypothetically, the first principal component that we get, Z1, is 3 times education plus 4 times experience plus 5 times tenure. Just for the time being, just understand that this is what we get. Now, it does not make any sense, if you're defining a new variable where education gets multiplied by 3, experience gets multiplied by a scalar multiplication, tenure gets it loses its economic significance. Also, many times changing the units of measurement also changes the principal components substantially. Now, other possible remedial measures of removing multicollinearity from the regression equation is, it again runs on a logic which says that if your model suffers from multicollinearity, then changing the variable by a very, very small amount changes the regression results substantially. If your model suffers from multicollinearity. So detection of multicollinearity can be done through the variance inflation factor. And then what we do is, some of the observations of the variables, either we change it drastically or we transform the variable, and then we again run the regression results and just look at the sign and the magnitude of the coefficients that you get. If the coefficient changes in a drastic manner, that is, if the coefficient which was insignificant in the earlier model becomes significant in the true model, it gives you that it gives you an indication that your model suffers from this problem of multicollinearity. And that's why theoretically you'll find that one of the possible detection measure of the presence of multicollinearity in the model is a very high R square but insignificant T ratios. This is one of the possible method of detection method, at least theoretically, for the presence of detection of multicollinearity. So इसका भी रिमूवल का अगेन वही सेम क्राइटेरिया है. आप वेरिएंस इन्फ्लेशन फैक्टर हर एक वेरिएबल का निकालो, जिसका भी सबसे ज्यादा होगा पहले इसको रिमूव करके देखो. If it works, well and good. If it does not work, again just try and do some linear combination of the variables and then again run the regression. Then again calculate variance inflation factor, and if it is not that high, then again you simply assume that your model has been removed, or the problem of multicollinearity has been removed from the model, and then you go ahead like that. All right, so as far as variance inflation
Sir.
factor, yeah.
Sir, in variance inflation factor, how high can be the correlation? For example, यहाँ पे experience is 1.47 and tenure is 1.34. So they are almost in similar lines with each other. So कैसे पता चलेगा कि कितना high हो सकता है correlation?
One possible you see, there's this other factor which is called as tolerance factor, and tolerance factor is 1 upon this VIF, that is variance inflation factor that you get. Now, कितना ज्यादा correlation high होना चाहिए, that again I told you that multicollinearity is a problem of degree. See, problem becomes severely intense when the correlation coefficient is 1. In that case, the variance, that is even in the variance formula, if you notice, 1 upon 1 minus rj square. If rj square becomes completely 1, you have 0 in the denominator. In that case, variance goes to infinity. and that's where the problem lies. So in this, taking example in this particular case, यहाँ पे experience का variance inflation factor मुझे ज्यादा लग रहा है. Suppose in this example, it is not very high compared to tenure, but it is higher than that of tenure and education. So what we do is we first remove the variable experience, because you understand that experience and tenure of an individual tend to be correlated or tend to be highly correlated with each other. So we either remove any of the variable, then again run the regression, again calculate variance inflation factor and check whether we have the problem of multicollinearity or not. But one thing you always remember is that your R square value should not be sufficiently close to the value 1. In that case, you have a severe problem which needs to be corrected as soon as possible. Because your variances will go to infinity. In that case, any estimation on the basis of these OLS estimators will be you cannot actually get the confidence interval because you have the infinite variance. So one thing that you must be clear, that in the presence of multicollinearity, your OLS estimators remain unbiased. Variances also is unbiased, but the estimation of variance in the presence of high multicollinearity, or in the presence of near perfect multicollinearity, goes for a toss. So jitna bhi confidence interval in the presence of multicollinearity hoga, that will be a faulty confidence interval. That is one of the severe consequence of multicollinearity. So एक जनरल रूल आप ये लिख सकते हो कि अगर आपका R square is sufficiently close to, let's say, 90% of any one explanative variable against the other explanative variables, meaning which क्या बोलता है इसका मतलब कि 90% of जो variation है उस particular explanative variable का, it gets explained by the other explanative variables that you have already included in the model. So जो भी partial influence होगा इस explanative variable का on y, it would definitely have been covered by the explanative variable already you have kept in control in the multiple linear regression model. And that's why you can be, or you're free to remove this variable out of the original equation. That's how we try to go with the remedial measures of removing multicollinearity. ठीक है?
Yes, sir.
So R square का value check करना, अगर 90%, because having a very high R square will give you a sufficiently high variance inflation factor. So जितना ज्यादा होगा वो denominator उतना छोटा होते जाएगा, उतना ज्यादा ratio बड़ा होते जाएगा. और tolerance factor is exactly 1/VIF. So tolerance factor जिसका minimum होगा उसको आप you simply हटा दोगे अपने model से. All right.
Yes, sir.
Okay. Now let us go ahead and try and find out our command for the joint hypothesis that we had discussed in the matrix method. So individual t-test of significance, you can easily see it can easily be got by this table, where t-test of significance mainly runs on the idea that एंड एक और चीज हमेशा याद रखिएगा कि ये जो आपका कोएफिशिएंट जो टेबल आता है, इट ऑलवेज इज बेस्ड ऑन द नल हाइपोथेसिस ऑफ no significance. That is, your null hypothesis always in such cases is that the population coefficient of all these estimators are equal to 0. So if you are saying that significant t ratios, all it means is that the true population coefficient of all these variables is significantly different from 0. That's why they're called as significant t ratios. So always remember this point. So the individual t test of significance है, उसके लिए you need not worry, because it can automatically be obtained from these coefficients. The problem of having a joint hypothesis where we are testing the hypothesis jointly, that is, we have more than one simple hypothesis joined together, that's where having a simple command on our software will be really helpful. So let us try and understand with one example that how do we exactly run an F test, which is used for the joint hypothesis testing with R. And for this, uh, I take the data set, which is your, these are the data set of American basketball leagues. So the data set is stored as MLB1. Again, the package is this is a data set exactly that we have in front of us. This is a salary of those league players. Team salary is given, years of playing, number of games, so runs, hits, doubles, jitna bhi home runs, बैटिंग एवरेज. सो ये सारे वेरिएबल्स हैं इस पर्टिकुलर डेटा सेट में. What we simply do is we try to estimate a relationship between the log salary
So what is the
of these
name
players.
of the data set?
It is MLB1,
Okay, sir.
right? So just again in this case, we run a regression of log salary against years, number of games in year, batting average, home runs year. So let me just run the regression and let me call it as RES1, or let's say REG. I'm running this regression of LM of L salary. So I'll simply write it as L salary against years. All right. So you can simply get the coefficient of this regression. So these are the intercept along with the slope coefficients that we get. Now, let us say someone comes up, someone is actually trying to find out again this estimated relationship and says that, once you have years of experience and number of games in year in control of the multiple linear regression, then the batting average and home runs per year and RBISYR, this variable, does not explain any movement in logarithm wage or wages or salary earned by that player. So basically now my hypothesis is that coefficient attached with BAVG, batting average, H, home runs per year, and RBISY, I don't know what is the description of this. You can see the, just writing description data set, it will come. So RBI, so all these three explanatory variables that we have here, my joint hypothesis is that all these three explanatory variables are zero. Now, how do we go about this? So in this case, my null hypothesis kya hoga? Anyone? What will be the null hypothesis in this case?
Beta 4, beta 5, and beta 6 are all zero.
Correct. So alternate hypothesis kya hoga?
At least one of them is non-zero.
Correct. So now let me just introduce one term here, which is called as restricted regression and unrestricted regression. So unrestricted regression का मतलब क्या है? जो आपने original model run किया, that is in this example, this is your unrestricted regression. Now restricted regression क्या है? Assuming your null hypothesis to be true. So if you assume that your null hypothesis is true, then this coefficient attached with BAVG, home runs here, RBI, SYR need not even be included in the model. So this will be called your restricted regression. That is, once these restrictions which are imposed on the earlier regression is true, it can easily be done away with. That is, you can simply remove these coefficients from the original regression. Okay, this is how you define the restricted regression and unrestricted regression. Unrestricted regression is the regression equation containing all the intercept, all the coefficient along with the intercept terms. Restricted regression is जिसके against आप hypothesis test कर रहे हो. In this case, my null hypothesis is that the coefficient attached with, in this case, beta 4, beta 5, sorry, beta 3, beta 4, beta 5 is equal to 0. And it is not a simple hypothesis. That is, I'm not running an individual test of significance hypothesis, meaning which I'm not saying that beta 3 equal to 0 or beta 4 equal to 0 or beta 5 equal to 0 at one time. All I'm saying is that combinedly beta 3 equal beta 4 equal beta 5 is equal to 0. And that's why it becomes an example of joint or combined hypothesis, compound hypothesis. And in this case, usual t-test of significance will not work. So when you have such cases where you're talking about a joint hypothesis, such test of significance can be calculated using what is called as F test. Now, F test kya hai? F test simply runs on the formulas that we have got. So if you have these restrictions and these restrictions are imposed on the original regression, so you'll have two regression that you actually run. First is your unrestricted regression, where you run the regression assuming all the coefficients are non-zero. You obtain the R square from this regression. Then again, you run the regression assuming or imposing the restrictions on the original regression, meaning which in this case, beta 3, beta 4, beta 5 equal to 0. So you'll run the regression imposing these restrictions. You'll call this as restricted regression. You'll obtain R square from this regression. And then the F statistic is defined as, please listen to this very carefully. I'm not using whiteboard, so it is difficult for me to write here. So now in this case, F statistic is defined as R square from the unrestricted regression minus of R square from the restricted regression divided by, obviously F statistic है तो degrees of freedom से defined हो, ये सारे chi-squared independent variables हैं, divided by degree of freedom. In the denominator you have 1 minus R square from the unrestricted regression divided by degrees of freedom. Now the question is, what will be the degree of freedom in the numerator and what will be the degree of freedom in the denominator? So in the numerator, where you have the differences between the R square from the restricted and the unrestricted regression, the numerator has the degrees of freedom which is equal to the number of restrictions imposed. I'll repeat this again. The degree of freedom in this case is the number of restrictions imposed And degree of freedom in the denominator will, as usual, be n minus k, excluding if you're if you're including the intercept, then it will be n minus k minus 1. If you're excluding the intercept, then it will be simply n minus k. So in this particular example that we have talked about, the degree of freedom for the numerator will be 3 because we have imposed 3 restrictions. And in order to talk about the degree of freedom in the denominator, you simply just look at the dimension of this data set. It will give you the number of observations. So it has 353 number of observations. And in total, we have 6 number of explanative variables, including constant. So we simply 353 minus 6, that will be our degree of freedom in the denominator. Again, I'll repeat this point. This is a test where you test for joint hypothesis.
Excuse me, sir.
Yeah.
Could you please tell what again restricted is? Like restricted is we are putting some constraints that we are only taking one at a time, right?
Yeah, restricted regression is assuming your null hypothesis to be true, जो भी आप restrictions impose कर रहे हो original regression में, that becomes my restricted regression. So in this case, my restricted regression will be regression of L salary on years and games YR. Unrestricted regression will be this entire regression. Why I'm calling it is restricted and unrestricted, इसको logically आप ऐसे समझो. Suppose ये मेरा original regression equation है, and then you are running a hypothesis, that is your null hypothesis is that the coefficient attached with these variables are equal to 0. So अगर आपका null hypothesis you are not able to reject, then the original equation is reduced to regression of L salary on years and games YR only. And if your null hypothesis you are not able to reject that, your your original model remains this. So the unrestricted regression equation is that equation which you run assuming all the population coefficients are non-zero, or assuming that there are no such restrictions on the regression equation. Whereas restricted regression equation is that regression equation which you run keeping in mind the joint null hypothesis. Then it is all about comparing the F statistic that we calculate. We calculate R square from both the regression equation. Then the F statistic is defined as the difference between R square from the unrestricted and restricted regression divided by number of restrictions imposed as degrees of freedom. And in the denominator, you have 1 minus R square from the unrestricted regression divided by degrees of freedom, which in this case is n minus k, if you're including the intercept.
N minus k minus 1, right?
Correct. If you include the intercept.
Okay, okay,
चलेगा?
okay. Yes, sir.
ठीक है? So इस example को, this same example, we do it manually, and then we again do it by simple using linear hypothesis command, which we'll use later on. So क्या है step? First step is you calculate R square from the unrestricted regression. ठीक है? So I write it as R square unrestricted as summary of this variable reg. And in order to find out R square from the summary, you can simply have the dollar sign and you can simply write r squared. So what we have done is, by this command, what we have done is, from the summary of regression results, I am just taking out r squared of that regression. And I store this variable as r2ur. So I simply write this. Okay? Then I'll run the regression, that is restricted regression. I can store it as reg1. It will be lm, again L salary. Now I'll only use two explanatory variables. So you'll see now this becomes my restricted regression, assuming that the null hypothesis, that is my joint hypothesis, is true. So basically जो f statistic हम निकालते हैं, that is a statistic to compare these two models. If you are able to reject the null hypothesis, that is, if you are able to reject the calculated f statistic according to the critical value, what it means is that your first model is true. And if you're not able to reject the null hypothesis, it means your second model is true. So ये मेरा unrestricted regression है. Again, I'll simply do the same thing. I write it as R2 restricted, and I can get again the same thing as summary of what reg1, और इससे मुझे क्या चाहिए? इससे मुझे चाहिए r square. I'll simply write it as. ठीक है? So I've got r square unrestricted, r square restricted. Now I'll simply have the f statistic. Let me write it as. So f statistic will be defined as numerator क्या होगा मेरा? Difference between r square from the unrestricted and r squared from the restricted regression. So I'll simply write it as r2.
Sir, एक second, we're writing.
Yeah. हाँ.
So REG1 becomes auxiliary then? Do we call it that?
नील तुम्हारा वॉइस ब्रेक कर गया. Could you please ask again?
Sir, वो जो REG1 है, are we calling that the restricted model or the auxiliary model?
Restricted model.
Restricted model. Okay, sir.
Yeah.
Okay. Thank you, sir.
Yeah. So now the f statistic will be defined as the difference between r square from the unrestricted regression and r square from the restricted regression. So I'll simply write it as divided by degrees of freedom, which we can simply write in the later on as well. That is multiply हम कर देंगे ऊपर नीचे. Just write the denominator part first. So my denominator will be 1 minus r square from the unrestricted regression. And now this whole thing, since the degrees of freedom of numerator is in ratio term, so the degree of freedom hoga, it will be inverse of what we actually write. That is जो numerator का degree of freedom होगा, that will be in the denominator part, and जो denominator का degree of freedom होगा, that will be in the numerator part. So number of observation in this case is 353. In total, I have 6 numbers of explanatory variables, including the intercept. So I simply take 353 minus 6. That will be my degrees of freedom for the denominator. So in that case, this will be 347. And for the numerator, the degree of freedom is given by the number of restrictions imposed on the model. In this case, I have 3 number of restrictions, so I simply write it as 3. Now I'll close this. Oh, let it be there. Yeah. So this will be my F statistic and I can calculate this. So F statistic comes out as 9.550253. Now, how do we exactly know whether this F statistic will be rejected or not rejected? We'll go to the F table with, and we'll see the number for 347 degrees of freedom and 3 degrees of freedom. We'll take that value, we'll compare the value that we get here. If this 9.550253 is greater than the F critical value, what it means is your null hypothesis is true.
Just a doubt,
So
sir.
null hypothesis being true means your first model is, so that is you're not able to reject the null hypothesis. In this case, this will qualify as that your first model is, that is, the coefficient attached with these batting average or home runs per year and the other variable is actually non-zero.
So
And if
just a
you're
doubt.
not able to, yeah,
So वो जो 347 है वहाँ पे, aren't
yeah,
we don't we usually do 353 uh -3 -1, so 353 -4. I'm not
नहीं
sure
थ्री
about it
क्यों होगा यहाँ पे नील?
because k k is 3 we're taking n minus k
K
minus 1.
is the number, yeah, K is the number of regressors in the original model, that is in the unrestricted model. क्योंकि डिनोमिनेटर में देखो, डिनोमिनेटर में आई हैव द आर स्क्वायर फ्रॉम द
Unrestricted.
अनरिस्ट्रिक्टेड मॉडल. सो जो k होगा दैट इज नंबर ऑफ रिग्रेसर्स आई विल बी टेकिंग फ्रॉम द अनरिस्ट्रिक्टेड मॉडल. न्यूमरेटर के डिग्रीज ऑफ फ्रीडम में आई विल टेक द, that is degree of freedom, as the number of restrictions. So number of
All right,
restrictions in this case is 3.
all right, all right, all right.
ठीक है?
ठीक है.
So जो k denominator में, that k you take it from the unrestricted equation.
ठीक है सर.
ठीक है? All right. So ये तो था कि मैनुअली हम कैसे रन करेंगे, knowing that how F statistic is, calculated. Now, I'm sure that you understand that इतना करने की जरूरत नहीं है हमें. There is this very easy command on R which is called as linear hypothesis command. वो क्या है वो देखते हैं. वो सेम चीज करता है, that is in this case we have compared the two models assuming the restrictions to be true. So that becomes my restricted model. And if the restrictions are not true, that becomes my unrestricted model. Then we compare the two model on the basis of F statistic that we have calculated. If we reject the null hypothesis, it means that the unrestricted model is the true model. And if we are not able to reject the null hypothesis, it means that the joint hypothesis that you have had, that is the coefficients attached with these variables are 0, is not rejected at whatever level of significance that you have had taken. Now, this same thing can be easily run by invoking the command which is your linear hypothesis. So for this, what we do is we simply run the regression equation as it is. So mera, yeah, so this is my unrestricted regression that I have ran. Then the next step is I have to test my joint hypothesis is, that is my null hypothesis is, that the coefficient attached with this BAVG, HR, UNSYR and RBISYR is 0. So for this, what I do is I define a variable. Let me write it as my H naught, that is my null hypothesis. And I can, in this case, I have joint hypothesis. So I can have a vector of whatever hypo. In this case, I have three restrictions, so it will be a vector of three, length three. If you have two restrictions, it will be a vector of length two, and so on and so forth. Now, I'll take each of this variable 0, now this becomes my null hypothesis. Simply write it here. And it is also not necessary on our part to write this 0 as well. 0 by default true mante hain as far as this vector, my null hypothesis, is concerned. Now what we do is, I have already called car uh, package, so I'll just simply write the command. The command is your linear hypothesis. You can see here, either I can use this or I can use this, so does not. Linear hypothesis on what? On the regression that I have ran. And what is your hypothesis? I'll simply write it as my H naught. Now you see, you'll get the same result. You see the F statistic here you get as 9.5503, which is the same. It does the same thing. You see, model 1 is your restricted model. Model 2 is the unrestricted model. F statistic का ये जो P value है, so you can see that this P value is very, very low. What it means? That the restricted model is not the true model. Means what? कि जो joint hypothesis है आपका, that joint hypothesis you reject. And what is the joint hypothesis? That the coefficients attached with these variables are jointly equal to 0. So it automatically means that at least one of the coefficients with either of these three restrictions that we have imposed is non-zero. So linear hypothesis is a command which we generally use for testing joint hypothesis. अब ये जरूरी नहीं है कि हमेशा मेरा joint hypothesis यही रहेगा. I can have plethora of combination of joint hypothesis, and I can still run my hypothesis as it is. The only thing that you have to keep in mind is that how you exactly define your null hypothesis is what matters. So in this case, someone can argue that it is not just about this going to 0. Someone says that actually batting average is 0, and let's say home runs per year or in this year is equal to twice of this. So suppose I want to test this hypothesis. How can I go about it? I simply do this. I go here. Now what I'll say, batting average is 0 and home runs is equal to twice of, let's say, RBISYR. Oh. Now this is my hypothesis. You can see again you get this linear hypothesis test result where you can see that the F statistic is actually having a very, very high p value, meaning which that your null hypothesis is not rejected. Is not, yeah.
Could you slow down a bit? We're still copying the code.
Yeah, yeah, yeah.
Getting difficult to understand.
नहीं, ठीक है. Just let me know once you're done.
Yes, sir. Just a minute, sir. Sir, in the first one which we
हाँ जी,
ran, first linear hypothesis,
हाँ जी.
uh, when we are checking that batting average equals to zero, are we checking for its coefficient or are we checking for the mean of all the values?
नो नो,
Or
कोएफिशिएंट बीटा, बीटा 4, बीटा 5, बीटा 6, जो कोएफिशिएंट हम अटैच करते हैं वो.
okay, and sir, how is the test understanding that we are writing that? I'm not understanding
या
that. Like
या
we are just
या करेक्ट.
writing my h naught. So
ठीक है, ठीक है. ये देखो, ये आपका ट्रू रिग्रेशन है जो आपने रन किया. ठीक है. Now you want to test this hypothesis. Your hypothesis is what? That in the presence of years and games year, which you have already included, no such variation in log salary is explained by these three variables. This is your null hypothesis. Okay?
all right, sir.
Okay? So this is your joint hypothesis. That is, you're saying that at one point in time, all these three variables or the coefficients attached with this three variable, they all are combinedly equal to zero. That is, they
Zero.
are insignificant. Okay?
But sir, the beta values of these, right?
Correct, correct. So it's simply the argument of this my null hypothesis is the variable name. We do not take the beta name. So argument इसलिए मेरा यहाँ पे variable है.
All right, sir.
ठीक है. So जब वेरिएबल इक्वल टू जीरो लिखते हो, यहाँ पे इक्वल टू जीरो नहीं भी लिखोगे, it takes this argument by default. It means that the coefficients attached with these argument or these variables are equal to zero.
Okay, okay, sir. Yeah, I was not clear with the.
ठीक है.
Yes, sir. Yes, sir. Huh, sir.
So B batting average equal to zero means the coefficient attached with the batting average equal to zero.
Okay, sir.
Similarly, this equals zero means the coefficient attached with this equal to zero. So this vector that I have defined for my null hypothesis takes argument is the variable name. ठीक है.
Yes, sir. Yes.
All right. And then we simply call library and use the car package. Car package में आपका linear hypothesis है, जो command है. We simply run this command linear hypothesis on what? On the regression results. And the next argument is my null hypothesis. So I simply write as my h naught. You can, instead of defining this variable, you can simply would have written here as well. That is my h naught is equal to c, that is vector this. Is this clear?
Yes,
So आप
sir.
यहाँ पे देखोगे,
Understanding.
या आप यहाँ पे देखो, ये आपका हाइपोथेसिस का वैल्यू देता है यहाँ पे कि बैटिंग एवरेज जीरो, दैट इज कोएफिशिएंट अटैच्ड विद ऑल ऑफ देम आर जीरो. सो इट कंपेयर्स बेसिकली टू मॉडल जो भी हमने पहले देखा था बाय कंपेयरिंग द एफ स्टैटिस्टिक मैनुअली. So it compares these two model. First model, restricted model, means you're saying that all of them are equal to zero, means you're running this model only. That is, you're running L salary on years and games year only. And the model 2 is assuming all these restrictions are not true. So this is the unrestricted model. So जो F statistic निकल के आता है, that F statistic actually is about comparing these two models. अगर F statistic आप reject करते हो, meaning which model 2 is correct. Model 2 is correct means that जो restriction जो आपका joint hypothesis है, that is not true. Is that clear?
Yes, sir. Understanding, sir.
Okay.
Sir,
Now
I have
next one,
now
yeah,
in the first case, the p-value is very less. That means all the three variables are actually not equal to zero, right? We are going to take the unrestricted model, right?
correct, correct, yeah,
Okay. And in the second case, here the p-value is greater, so we are saying that whatever h naught that we took is right.
is
That
right, yeah, yeah.
okay, sir.
ठीक है. So इस केस में देखो, अब यहाँ पे I think it was Mohit who had asked we understand compound hypothesis, joint hypothesis. We can have multiple number of hypotheses. Four is equal to twice of 5. I can also have 4 is equal to twice 3 plus 1. So I can have multiple combination of such hypotheses. similarly use
Sir, your
with
voice is
linear
breaking.
hypothesis command. Not clear my voice?
Sir, your voice is breaking.
Again, is it better now?
It's still breaking, sir.
One second. Is it better now, guys?
Yes, sir.
Okay, all right. So जो अब यहाँ पे मैं कितने भी combination of joint hypothesis test कर सकता हूँ depending on what exactly you want or what the question actually asks by simply writing this vector and running this linear hypothesis command. चलेगा?
Yes, sir,
So
understood. But
हाँ
I
जी.
have a very silly doubt actually.
अरे
Like,
बार बार मैं बोलता हूँ please don't use this
so,
term.
like I'm just asking you late actually. No, I have understood this question. I have a doubt in the first one. I tried to understand for a long time. Like if you
Yeah,
can scroll up to the very first some months,
this.
um, no, like a little down. Yeah, in this omitted variable case, yeah.
Yeah,
थोड़ा ऊपर करो. Yeah, in the last line, what you did, I didn't actually understand. Actually, your voice actually broke in the last class, and I had doubt yesterday only, and I couldn't ask.
yeah,
So,
yeah,
what you did in this last line, like we calculated the value of act, and then we, yeah, this line. Can you
yeah,
explain it?
yeah. देखो इसको explain करते हैं यहाँ से. So 1 second. So this is my original regression equation. That is assuming that this is a multiple linear regression and it contains two explainative variables. ठीक है? That is actual regression जो है in this example is including high school GPA and achievement test score. Correct? So ये in this case जो beta coefficients आपका आता है that is this value. So ये beta coefficients को हम कैसे explain करते हैं? They are partial regression coefficient. That is HSGPA के अगेंस्ट जो बीटा लगा हुआ है that gives you the partial regression of HSGPA on expected value of y keeping ACT constant. ठीक है?
Yes, sir.
And same interpretation for ACT. Now assume that you forgot to include HSGPA explicitly in the model and instead you simply ran a simple linear regression model. So you ran this model of college GPA on achievement test score and you got this estimate. अब ये estimate क्या बोलता है आपको dear? This estimate is actually the influence on a average value of y due to a unit change in achievement test score.
Yes, sir.
Is that fine? ठीक है? And you can see that these two estimates are substantially different from each other. That is, the estimate or the coefficient in the presence of high school GPA of ACT on Y is very significantly different to that of this coefficient attached with ACT in absence of high school GPA. Right?
Yes, sir.
And in this case, you see, this estimate tends to overestimate the influence of achievement test score on Y because this is greater than 0.009. So true estimate ये है, right? But जो आपने in absence of high school GPA run किया है, उसमें आपका जो estimate आता है वो आपका ये है. So it means estimator is biased.
Yes, sir. It's overestimating.
या अब वो कैसे मुझे पता चलेगा वो ओवर एस्टिमेट और जो omitted variable bias है. Now a logical reasoning is that when you ran this regression, this coefficient attached with ACT gives you a direct influence of y, and if I'm saying that it is a relevant variable, it means the variable which you omitted, there must be some correlation between the omitted variable and the independent variable in the model. So what you do next is you run a correlation or you run a regression. it's a simple linear regression, so I'm using correlation coefficient and regression interchangeably. So you run this regression of college GPA on, sorry, high school GPA on achievement test score, and then this coefficient is what? It is the correlation coefficient of high school GPA with achievement test score. So what it means now, कि when achievement test score increases by 1 unit, high school GPA score of individual also increases by this many units. And in the original equation, high school GPA also influence expected or average value of y. That is, when ACT increases, it directly leads to increase in y, but it also has an indirect effect through its increase or through its correlation impact on high school GPA. And when that high school GPA increases, y also increases due to that. So जो omitted variable bias है, that bias I calculated, that is this estimator that we have got, this must be equal to the true estimator from the population regression coefficient plus the correlation coefficient of the omitted variable or regression coefficient of the omitted variable with the achievement test score multiplied by the regression, or sorry, partial regression coefficient of the omitted variable in the true equation. And this is what I have done. I have taken the ACT coefficient from this regression, that is true ACT, true coefficient, plus coefficient of HSGPA, which is this, and coefficient of ACT from the regression of HSGPA on ACT, which is this. And when you calculate this, you can see that this estimator and this value of the estimator is exactly same. So what it means is that when you have a case of omission of relevant variable, you have a case of biasness. And that biasness is called as omitted variable bias. Now that bias is defined by the correlation coefficient between the explained variable and the omitted variable and the true population regression coefficient of the omitted variable. Is this clear?
Okay, sir, but just basically we can actually see it is overbiased from the first two equation itself, that the coefficient of ACT should have been 0.009 and we are getting 0.027. It's much higher, so it's overbiased,
Correct.
overestimated. So from the first two equation itself, we can conclude that, but we are just proving it, right, with this
Correct,
thing.
correct. Yeah. We
Okay.
are just calculating that omitted variable bias. That is bias आपका ये term बताएगा. This term gives you bias. Otherwise, you see, if either of this is zero, that is either correlation coefficient of omitted variable with the explained variable is zero or true population regression coefficient of the omitted variable is zero, then
Then there
the
should be no bias. Actual
exactly,
value.
then there should not be any change that we get.
Okay, sir. Understood. Basically, the difference is the bias. I understood, sir.
Correct, correct.
Thank you, sir.
Yeah. All right. So
Sir,
yeah.
if,
हाँ नील बोलो.
the F का जो हमने manual calculation किया था, so could you
Yeah.
please put that code in the chat box, because I'm getting a value of 64 after doing my calculation.
Yeah, sure, sure. ये वाला ये डालूं.
ML हाँ unrest r2.ur वाला, yes sir. So can you send from r2.ur 4 line ऊपर?
हाँ, one second. यहाँ से.
हाँ sir, thank you sir.
So,
हाँ जी.
so instead of manually calculating the omitted variable bias, isn't there some way that itself calculates it and tells us which variable is bias?
Again, it does not give you that, Ayushi. If there would have been way, I would have told you.
Okay, sir.
ठीक है? Yeah. All right, shall we move ahead then?
So, sir, if we have more number of
हाँ जी.
explanatory variables, I have to run each time a simple linear regression of each variable.
Yeah, that is itself a problem, yes, but it has to be done.
Okay.
Yeah. Okay, shall we go ahead then? Aage?
Yes, sir.
All right. So, moving ahead, we'll just learn to use the predict command जो हमने एग्जाम्पल किया था मैट्रिक्स मेथड के थ्रू. We'll just try and see how exactly we can obtain the prediction using linear regression model on R, because ultimately after you run the model, after you estimate the model, the next thing that we intend to find out is the prediction of the model, whether the prediction that we do is an accurate one. We find out the confidence interval to just to be जैसे हम बोलते हैं कि जीडीपी ऑफ इंडिया अगले 5 साल में प्लस माइनस ये टर्म होगा. So let us try and find out an example where we talk about how do we exactly use the predict command from the regression results. So let me just go through that. For this, what I do is I take the data set voltage, and again check. So this is the data set that I have in front of me. What I wish to do is I wish to learn to use the predict command. So prediction के लिए क्या चाहिए मुझे? Prediction के लिए first of all I need to have the regression model. So simply I'll just run the regression. Run the regression. I'm running this regression of COL, GPA, SAP, SPRC, size. Now I want to include a polynomial term for this h size variable. How do I go about that?
You use the alphabet I.
Correct. I size square.
So when exactly do we use this polynomial term?
That again, see, when your model requires not just explanatory variables, not just in terms of linear power, but let's say, जैसे यहाँ पे is this case में, what we are saying is that when you have polynomial terms and then when you calculate the slope coefficient, you'll still have the average value of COL GPA depending on the current value of H size. What it means is it tells you that this elasticity of the dependent variable with respect to explanatory variable is just not, it just does not go out of the picture by just taking the first differential. It also depends on the current value of the explanatory variable that you talk about. So basically your theory, it's like when you are trying to estimate a cost function, you cannot have a cost function which is estimated just in a linear fashion. You and that's why the cost function you have, it does not look linear in nature. It gives you an inverted S shape. So wherever, when you're plotting the response variable against the explanatory variable and then you find out a curve pattern, more often than not, there you use the polynomial terms or logarithmic term or exponential terms. So कहाँ पे polynomial actually use करना है, that you can actually learn when you plot the dependent variable against the independent variable. ये basically क्या है? अगर आप देखो तो this is y is equal to beta naught plus beta naught for intercept. I'm just not speaking it now. So beta 1 plus beta 2 plus beta 3 plus beta 4 x4 का square. So what it means that this y, which is college GPA, it is a polynomial function of h size. So when you
So
witness a,
beta 4 x3 का square, because we've already used it as
sorry,
x3.
x3, correct, x3 जो भी है, तो ये जो variable है, this has a non-linear relationship with the explained variable. So in that case, we use the polynomial terms.
So,
ठीक है? हाँ जी.
so then why not just include the polynomial variable and not h size itself?
Why not include?
The polynomial variable just itself and not h size.
See, how do you write your polynomial equation? It is, ax plus bx square plus c. Now, why do we take x there? Why just we do not have bx square term directly? You see the reasoning here? What it says is, now you see, जो coefficient होगा h size square के पास, when you take the differential of this h size square with respect to y, so when you take the differential of y with respect to h size or this particular variable, what it will say is that it is not only h size which influences y, but the squared power of h size which influence y, because when you take that first order differential, h size term will still be there. It means if you're trying to find out the expected value of y with some hypothesized value of h size, so जो आपका slope term होगा, that will be dependent on the current value of h size. That is, it will not be independent of the h size value. Now, why do we take this h size square? What it says is, if you just take h size square, what you implicitly say here is that y and x are not linearly related. There is only a squared relation of y with respect to x. So if we just take h size square and omit h size from the equation, what we encounter or what we will encounter in this case will be a problem of again omission of that relevant variable. So that x term, it justifies that. You see why you get a curvy linear pattern or curvy pattern. जब टेलर सीरीज एक्सपेंशन सभी आप करते थे, if you approximation जब करते थे, so Taylor series approximation approximates a curve to a linear pattern. How it does that? It takes each of those non-linear powers of x and it approximates that function according to those non-linear power. So including just x square term means you are taking the x in the error term. But y might be linearly related to x.
Got it, sir.
ठीक है? So h size आप यहाँ पे अगर include नहीं करोगे, if it is a relevant variable, this h size will be in that case will be in the error term, and in that case your error term will not be uncorrelated with the regressor. And in that case you will encounter that problem. और polynomial term हम किस basis पे include कर रहे हैं is by looking at the graphical relation of y with respect to h size. And that's why we include both the both the terms here. That is, we take the second power of h size and the first power, or that is linear power of h size as well. ठीक है, जब हम लिखते हैं polynomial equation, so when you write y is equal to, let's say, ax square, and you just do not take that bx wala term, that has a different graphical equation to to the case. When you simply write y is equal to ax square, that parabola passes through the origin. But when you add that plus coefficient time that linear power of x term, the graph becomes different. And that's why, including this h size in the regression equation itself is important, because it changes the otherwise relationship that you had actually obtained from the graphs. ठीक है?
Yes, sir.
So इसलिए h size और s size square दोनों मतलब in this particular example necessary है. जैसे आप कॉस्ट फंक्शन भी करते हो तो क्या होता है, कॉस्ट फंक्शन इज अ cubic function. Cubic function, it does not directly say it only depends on x to the power 3. It might depends on x square and then x to the power 3. What it says is that the highest power on which it depends is the cubic power or cubic function of x's. ठीक है?
Yes, sir.
All right. So coming back to this example, so what we have done is we have simply run this regression of call GPA against these explanatory variables. And then what we intend to do is we, जो भी मेरा regression result आता है, इसके basis पे we want to predict some or predict the values. So let me just find out a summary. All right. So actually, how will I write the model? 1.49 plus 1.49 times minus 1.386 times minus 6.008 times minus, plus 5.46 times these variables. Now, let us say I give you certain hypothesized values for SAT score, high school percentage, and H size. So what I say is that let's say we define it as C values. This is the variable name. And I ask you to find out the predicted value of y, say expected value of y, when the SAT score is this, high school percentage is this, and H size is this. So this is how I store my variable. So I say data frame, जो भी आपका hypothesized value है, you just write this. Again, I've taken the example from Woolies only, so the numbers are the same. So this is the three hypothesized value on which I want to find out the predicted value. So how do I go about it? I'll simply call this predict command. Prediction of what? Prediction of the regression equation that I've ran. With respect to what? With respect to the values that I have stored for this. So now you see, it gives you predicted value of y with respect to the values of explanatory variables which are mentioned here. Now, why just stop at one
I'm so
possibility?
sorry, I'm not understanding what that predict is doing with the C values.
Yeah, ये C values नील इसे देखो, ये prediction on what? Prediction on, you see, just give me a second.
So assuming that SAT score is 1200 and HS work score is 30, H size is 5, and given that the betas are from the regression model, what is the value? Is that
correct, correct,
all right? All right.
correct. See, if you just simply write predicted value of REG, what it gives you is predicted values of Y for each of those n observations. That's why you have this many observations. What I have done now is I do not need all the predicted values. What I'm doing is I am calculating the expected value of Y, that is predicted value of expected value of Y, when some of the explanatory variable, in this case SAT score, HS, high school percentage, and H size takes on this value. That's what I did with this. So I use predicted and what with respect to C values.
So does it have to be a data frame, or can we also just have like a simple string like C,
Uh,
C like,
you see, why generally we call it as a data frame? Because first of all, जो variable length है, it should be similar for all the hypothesized value that we have, and mostly ये जो hypothesized value or unknown values or known values of explanatory variables जो हम लेते हैं, that we generally store it as data dot frame. आप दूसरे फॉर्म में भी स्टोर करोगे, it will not change anything, but as far as this command, predict command, using this it works better with the data dot frame object type. तो अदरवाइज कोई ज्यादा डिफरेंस नहीं है, आप कोई भी यूज कर सकते हो as long as you satisfy these the variable length to be equal in there. So you can store the variable in any form, it does not matter. Now instead of one value, I can also define, let's say, multiple values for these explanatory variables. So again, what I do is I have the same data frame, and now sat, let's say there are three values, so let's say 1200, 900, 1400. Similarly, you have this as three values. Now there are three values for each of these explanatory variable, and now you want to find out what is the predicted value of expected value of y when the SAT, high school percentage, and H size takes on these values. So what I'm doing now here is I'm taking three values for each of these explanatory variables, and I want to find out what will be the predicted value of expected value of college GPA. So again, what I do is I just call the predict command. Prediction on what? Prediction on regression results, and then C values. So these are the three values that I get. So the first value should be understood as that expected value of y when SAT takes value 1200, high school percentage takes value 30, and H size takes value 5. Second is expected value of y when the individual has a SAT score 900 of 20 and high H size is 3, and so on and so forth. So with this predict command, what we are able to do is, when we have the model, after estimation of the model, we can actually test whether our model predict. So suppose in this case, जो भी हमने यहाँ पे values लिया है, these values I did not use for the model estimation purpose, which you can understand from the example that we had talked about, the training and testing purpose. So let's say these three values I had kept for testing the model. And if my model is actually correct, so the expected value of y for these three values of explanatory variables that I get must be approximately very close to the actual observation जो होगा मेरे पास for the SAT score, high school percentage, and H size with respect to these y. So using predict command, we can actually talk about prediction of the expected value of y on the basis of hypothesized values of explanatory variables. Now, one last thing that we'll talk about is the example of reset test. That is, how do we actually detect if the model that we have run suffers from functional form misspecification? Let us understand the theory first, and then we go about how do we actually go do this. So theory क्या बोलता है? if your model form miss specification, then whatever model you fit, उसका जो fitted value होगा, if I again include those fitted values and higher order powers of those fitted values in the regression, because these fitted values are nothing but the linear combination of the true regressors that you have in the model. So if your model does not suffer from any functional form misspecification, coefficient attached with these fitted values must be zero. And if it's a
Sir, your
functional
voice
form
is
specification,
breaking.
it's still breaking. Can you hear me now properly?
Yeah, now you are audible.
Yeah. So what you're saying is that if your model suffers from functional form misspecification, then the coefficient attached with the fitted values of the regression must be non-zero. So let us just try and understand this, what we are saying. And for this, I have taken the data set is, so this is my data set. And what the example has done is it has run a regression of price on lot size, square feet, bedrooms. So let us run this regression. Let me call it as original regression. So LM price on what I have done with bedrooms plus square feet and plus lot size. All right. So this is my original regression equation. Now what I do is I want to test whether my model suffers from any functional form misspecification or not. So idea क्या है? पहले उसको देख लेते हैं. Then we again do this. So idea क्या है? First you get the fitted values from the regression. So what I do is let me define a variable. Fitted value of, so I have stored the fitted values of the regression from this original regression equation as t. Now the reset test क्या बोलता है उसको समझते हैं. So let me write it as reset regression results. I'll again run the same regression, that is I'll again have the same dependent variable on the list of explanatory variables. Now what I'll do is I'll add the polynomial terms of the fitted values of the original regression. So I'll say I t square I. Now this is one of the major limitation with the reset test is it does not actually tell us कि कितने polynomial powers तक हमें रुक जाना है. But mostly the third order power of the fitted values should work for you. So data h price 1.
Sir, excuse me.
So let us get the summary of this regression result. Yeah. हाँ.
सर आपने वहाँ पे t
Yeah,
equals
बोलो
to
नहीं.
fitted of original लिया है. So just,
हाँ जी.
I was just asking, why have you taken that fitted of original? I'm a little confused.
Yeah.
सर आई एम आस्किंग व्हाई हैव you taken that fitted of original,
Yeah, yeah,
वो क्यों मुझे समझ में नहीं आया.
yeah. You see, idea क्या है नील कि suppose I ran this original equation. This is my original regression equation. Now I want to test whether my model suffers from any functional form misspecification or omitted variable case. So in order to test for that, there is this reset test, that is regression specification test. What it talks about is, what it says is that you run the original regression as it is, you obtain the fitted values from the regression, and in order to test for the presence of misspecification of functional form, you take the second and third power of the fitted values of the original regression. Now, the idea is that if the model suffers from any functional form misspecification, then the coefficients attached with the polynomial powers of the fitted values of the regression equation must be zero, must be non-zero. Because these fitted values are the linear combination of these regressors that we have in the model. So अगर इन polynomial terms जो fitted values हमने obtain किया उसके coefficient in this reset test is non-zero, it automatically means that your model suffers from some form of misspecification.
Sir,
Either there is yeah,
uh, t basically becomes y hat values.
correct.
Okay, so sir, in the reset reg, we can
Yeah,
also write price tilde t, मतलब वो पहले तीन टर्म को हम t भी लिख सकते हैं ना, कि
पहले
वो
टी
गलत हो जाए.
नहीं, नो वो गलत हो जाएगा,
अच्छा ठीक है, ठीक है.
है ना?
Okay sir, okay sir.
Because the auxiliary regression in this case is running the same regression, taking the dependent variable t, taking the dependent variable price on the original regressors, which in this case is this, and then I add two additional regressor, which is the polynomial powers of the fitted values of the regression, and test whether the coefficient attached with this polynomial power is zero or non-zero. ठीक है?
Yes, a little, yeah, a little bit.
So again it becomes the same thing. आप इस पे f statistic run कर सकते हो जो हमने usual किया था. So I can do this same thing here. What I do is I define my h naught as c. I write it as I t square equals 0. I t 0. Mm. Yeah. So I can do the same thing, linear hypothesis on what? On the reg and my h naught. Mm.
So the bracket should be closed after t to the power 2, I think. Equal to 0.
Yeah, you're
Yes,
right.
sir, I agree with you.
Yeah, doing like this. Yeah. Well, let me write it like this. ठीक है.
Sir, you named ORIG, not REG.
ORI. अच्छा हाँ, yeah.
सर आप इक्वल टू जीरो लगाना भूल गए.
नहीं, इक्वल टू जीरो बाय डिफॉल्ट आता है नील.
अच्छा
I
अच्छा.
need to do it. Yeah. Let me do it on reset RAG. Yeah, it should be done on reset RAG, not over IAG. So in this case, you see, my hypothesis is that the coefficient attached with the fitted values or the polynomial powers of the fitted values is 0. And you can see the F statistic has a p-value, which is almost 1%. So having a very low p-value means rejection of the null hypothesis. And my null hypothesis is, in this case, that the coefficients are equal to 0, meaning which the true model is actually, in this case, this, that is model 2. But
Could
the
you please repeat
limitation
that?
of the reset test is, yeah, F statistic का value जो है, that is very less, meaning which that you are not able to, you are able to reject the null hypothesis. So rejection of null hypothesis means मेरा null hypothesis क्या है? That the coefficients attached with the polynomial powers or the fitted values is 0. Uh, yeah, that the coefficients attached with the polynomial power are equal to 0. So rejection of null hypothesis means that actually this, the restricted model is what? Without inclusion of these two additional variables is not true. Meaning which that your model suffers from any form of functional form misspecification. Now, one limitation here is it actually does not tell us which, variable, which functional form. It just gives an indication that your function or the model that you have actually estimated is not correctly or fully specified. But reset test sufficiently works as far as indication of this functional form misspecification is there. So reset test mainly is, or देखो एक reset test was also used in the detection method of heteroscedasticity, but वहां पे और इसमें थोड़ा सा डिफरेंस है. डिफरेंस ये है कि यहाँ पे original y को ही we are again regressing against the fitted values of y, but in the detection of heteroscedasticity we were regressing the squared residuals on the fitted values of y. बट अगेन द टेस्ट मेथड मोर लेस वर्क्स ऑन द सेम वे. लॉजिक यही है कि अगर मेरा मॉडल फंक्शनल फॉर्म मिस स्पेसिफिकेशन नहीं है, तो जो भी कोएफिशिएंट है, the polynomial powers of the fitted values, the coefficients attached to these polynomial powers must be non-zero if my model suffers from any functional form misspecification. So reset test only gives you a way or a method to detect the presence of functional form misspecification, but it does not give you any indication कि कौन सा actually functional form या कौन सा actually variable missing है.